Morning, everyone. It's me again, Alex. So now this is the next examples on the design of shaft. So now let read out the questions first. So here you have determine the dimensions of a hollow shaft with a diameter ratio of 3:4, which is to transmit 60 kilowatt at 200 rpm. The maximum shear stress in the shaft is limited to 70 megapascal and the angle of twist is limited to 3.8 degree in a length of 4 meter. For the shaft material, we take the shear modulus or the modulus of rigidity as 80 gigapascal. So based on this question here, you have to consider the strength relationship based on the limiting shear stress and the stiffness or the rigidity relationship, which based on the 3.8 degree angle of twist. So I have a note here. The two limiting conditions stated in the questions, namely the maximum shear stress and the angle of twist, will each lead to different values of required diameter. The larger shaft must then be chosen as one for which neither condition is acceded. Okay, so here you have, so based on strength relationship, then based on the power and the speed given, we can find out the torque transmitted by using this power formula here. Sometimes it is written as T omega, which omega is the speed in radians per second. But in the case when the speed is in revolutions per minute, then you take the 2 pi n over 60. If it is in radians per second, then you don't have to times with 2 pi or divided by 60. So from here, you have the torque transmitted by substituting the 60 kilowatt, that is times 10 to the power of 3, and the 200 revolutions per minute here. So you got a torque of 2860 Newton meter. Then from the polar moment of inertia, that's for hollow shaft, okay, the external diameter, power 4, internal diameter to the power of 4 divided by 32. So here you have, okay, based on this, the strength relationship, manipulating this equation here, so you will get J is equals to TR over shear stress tau. So by substituting the torque, okay, and the shear stress with the radius changed to diameter over 2, okay, so you will have the J, the polar moment of inertia, as equals to this now, and which the external diameter is equals to 3 over 4 or 4 over 3. So this case is 4 over 3 times the internal diameter. 4 over 3 and it's not 3 over 4, okay? So you have d cubed is equals to 304.4 times 10 to the power of negative 6. So from here you can find out the external diameter of 67.3 mm and the internal diameter of 50.5 mm. So this is the diagram for the hollow shaft, and this is the polar moment of inertia for a hollow shaft. So the next part is based on the stiffness relationship. So that you have this equation here based on stiffness or rigidity, where you have, instead of shear stress over radius, now you have the modulus of rigidity, angle of twist with the length of the shaft. So manipulating this, so you have polar moment of inertia is equals to TL over G theta. So that is your polar moment of inertia, putting in all the values of T, L, G, and theta. So you have this, work it out, and then you got 2.156 times 10 to the power of -6. And why this becomes 1 and 0.75? Remember the ratio that we have got, okay? The external diameter is 4/3 of the internal diameter. So you have this, okay? And then this, and then from here you will be able to find the external diameter is 75.3 mm. That's based on stiffness relationship. And this is the internal diameter, 56.5 mm, okay, for the stiffness relationship. So now compare both the strength relationship and the stiffness relationship, comparing the external and the internal diameters that we have got based on both the relationship. Okay, so from this, as you compare, we will say, okay, the internal diameter of 56.5 mm will be adopted for the shaft design, the internal diameter, and the external diameter as compared, 75.3 mm is larger. So this value here will be adopted for the shaft design, for the hollow shaft design. Okay, so 75.3 and 56.5 has been chosen to be the external and the internal diameter for the shaft. Okay, so that's all for this slide. Thank you very much, and please, if you have any question, please put your questions or your comments on the comment section on the YouTube. Thank you very much. See you later.